Hey guys, in this video we would talk about another type of equilibrium constant called Kp, and this equilibrium constant is used when partial pressure of the gases is given instead of concentration in moles per liter. Let's take this up with an example. Let's say we are given an equation AA plus BB, and this is an equilibrium with CC plus DD. These are stoichiometric coefficients. In this case, Kp would be equal to partial pressure of the products, so partial pressure of C raised to the power of lowercase c times partial pressure of D raised to the power of lowercase d divided by partial pressure of A raised to the power of stoichiometric coefficient of A times partial pressure of B raised to the power of stoichiometric coefficient of B. Therefore, when we are given partial pressures in a question, then instead of using KEQ, because KEQ is for concentrations of products divided by concentration of reactants, whereas Kp is used for partial pressures of products and reactants. Let's do an example related to this. The first question is, in the decomposition of water vapor, equilibrium is established according to the following equation. All three entities are in gaseous states. At a given temperature, the partial pressures are found to be as follows. So we are given the partial pressure of water, we are given the partial pressure of hydrogen, and we are given the partial pressure of oxygen. We have to determine the value of equilibrium constant Kp. So we know Kp is equal to partial pressure of hydrogen, that's the first product, raised to the power of 2 times partial pressure of oxygen raised to the power of no number is 1 divided by partial pressure of H2O raised to the power of 2. We are looking to find out Kp, and we know all of these three partial pressures, so we would just sub in the values. Partial pressure of hydrogen is given to us as 1.15 raised to the power of 2 times partial pressure of oxygen is 2.67 divided by partial pressure of H2O is 0.63 raised to the power of 2, or square it, and then all we have to do to find out Kp is just put this in the calculator and get the answer, and we get 3.53 divided by 0.3969, and that is equal to 8.89. Therefore, we can conclude that Kp, or equilibrium pressure constant, is equal to 8.89, and that's our final answer. There could be a question asked in another form or another way. Let's do another type of a question. At 435 Kelvin, Kelvin is the temperature, Kp is given to us now 21.3 for the following reaction. Again, all the entities are in gaseous state, so we can use everything in equilibrium constant equation. So first let's write down the equilibrium constant equation, that is Kp. It's going to be the partial pressure of carbon monoxide, that's the product, raised to the power of no number means 1, partial pressure of H2O. If there is no number, we do not even have to put any number as a power, divided by partial pressure of hydrogen times partial pressure of carbon dioxide. Now let's see what we are given with. We are given Kp, we're given partial pressure of hydrogen, we're given partial pressure of carbon dioxide, we're given partial pressure of carbon monoxide, and we are required to find the partial pressure of water vapor. So we would sub in all the values that we are given. Kp is 21.3, partial pressure of carbon monoxide is 5.35 times, this is what we are looking for, divided by partial pressure of hydrogen is 0.84 times partial pressure of carbon dioxide is 1.31. Now we only have to isolate this, so we would leave partial pressure of water on the right side and we would move everything on the other side. We get 21.3 times 0.84 times 1.31, and then this goes underneath, so the whole thing gets divided by 5.35. We would just put this all in the calculator to get the answer. We get the numerator as 23.438 when we find the product of all these three numbers up there, divided by 5.35, and the final answer that we get is 4.38, and that's the partial pressure of water. And this is how we find out partial pressure when Kp is given to us.